Alright everyone, now it's time to try and figure out how the Wretch is going to figure out where he is in the wizard's environment. So remember, there are 4 regions. There's basically in front of him, which the Wretch wants to try to avoid. And then there's behind the wizard, where the Wretch is going to sneak in for an attack. And then there are the areas off to the sides where the Wretch is just going to basically do nothing and wait for the wizard to act and then react. So how does the Wretch figure out which of these regions that he's in? Well, basically, he needs to compare the direction that the wizard is facing. So this is what I've got represented here. By pulling this circle around, I change the wizard's direction. And this other value which comes from the Wretch himself. So what is the direction from the wizard to the Wretch? And that's what this value that I'm now adjusting represents. So if you can get these 2 values, then you can figure out where the Wretch is relative to the wizard, because you basically just subtract one from the other. So here, right here, we have the angle between these 2, and you simply get that by subtracting one from the other and then removing the minus sign if there is one. So if the difference between this angle and this angle is maybe, say, less than 45, something like that, in either direction, then we're going to count the Wretch as being within the wizard's line of sight. And we'll do the same behind the wizard. So if the Wretch is kind of within a certain distance of 180, so this is 180. If we add 45 to 180, we get 225. If we subtract 45, we get 135. So somewhere between 225 right here and 135, maybe. Something like that. We'll count that as being behind the wizard. So that just goes to show that what we need is this value and this value. We need to figure out what's the wizard's direction and what is the direction from the wizard to the Wretch. Now the good news is that the first of our problems has already been solved. So this variable here, direction, this refers to the wizard's direction, and it's set way back in the wizard sprite. So it says when the down arrow key is pressed, walk, and then it puts a number in here into these walk blocks, which determines which direction the wizard walks in. And these numbers are angles between 0 and 360. And so if you look down at walk, the block sets the direction equal to that input. So at any time when you press a key and you determine the direction of the wizard, this block here records it in the direction variable, which makes it available now to our Wretch. So that's great. So the other thing we need to figure out is the direction from the wizard to the Wretch. So let's make a block, call it set direction from wizard to Wretch, and then make a variable, direction from wizard to Wretch. And I'm trying to think, should I make this available for all sprites or just for this sprite only? Instinctively, I think it's just for this sprite, but then I'm wondering if later I will need it for the lightning or anything like that. The safest thing to do is to make it available for all sprites, I think, in this occasion. I don't think I'm going to use it, but I'd rather do that than have to fall back and redo everything with the new variable. Scratch doesn't make it easy to change this later. So I'm just gonna say for all sprites. So set direction from wizard to Wretch. So what is it? Well, an easy way to calculate it is to make the Wretch point towards the wizard and then turn 180 degrees. So like this. So point towards the wizard and then turn 180 degrees. And now he's pointing away from the wizard, which is the same as the direction from the wizard to him. So now all we have to do is set that variable, set direction from wizard to Wretch to whatever direction he's currently facing. So that's direction. Now, the only other thing we need to do is this is going to disrupt the direction that the Wretch was facing. So we're using the Wretch to figure out the direction by making the Wretch himself align with that direction. So what we want to do is we want to save his previous direction, do this little operation to figure out where the wizard is, and then go back to his previous direction so that it doesn't change anything. So we'll make a variable, call it Wretch direction for this sprite only. And before we do any of this calculation, we'll store the old value of his direction. So we'll say set Wretch direction to your old direction. So this just stores it in a different variable while we tinker with this. We then tinker with that, and then we set it back to its old value after we're finished with it. So point in direction, Wretch direction. So the purpose of this is simply to record the previous direction so that when we mess with it, we don't lose that information, and then we can just put it back in at the end. We have one small change to make. The Wretch direction is set in scratch degrees, which, if you remember, they're positive on this side, but they're negative on this side. However, the wizard's direction is written in regular degrees. So what we've got to do is we've got to put these in the same language. We've got to make sure that they're both set the same way. So we need to change this so that it's in regular degrees, so it's 0 to 360, not these kind of degrees from minus 180 to 180. Turns out that this is quite easy to do. So we're just going to reset direction from wizard to wretch to the old value to what it just was a minute ago, mod 360. And that transfers one to the other. How does it do it? It's a little bit counterintuitive, but the mod always ducks just under the value and returns the remainder. So if you've got, for example, if you've got 70 degrees here, what's the remainder when you divide 70 by 360? Well, it's just 70, because 0 times 360 is as big as you can get, and that leaves a remainder of 70. But what about when it's a negative 70? Well, in that case, what it does is even 0 is too big. Even 0 has gone past negative 70. So to duck under it, you have to go back even further. You've got to go back to minus 360 and then count round from here to get the remainder. But when you count round from here to get the remainder, well, that's the value that we're looking for, the number of degrees going clockwise. That's the regular degrees. So that's why that works. We're not going to spend too long explaining it, because for us it's just good enough that it works. Okay, we still haven't finished building this function, but we're getting there, and so let's take the next step in the next video. See you then.